The next variation to the smoothing models is what we call tracking signals. Here we're going to smooth the alpha coefficient, the smoothing constant. Instead of using the same alpha coefficient in the simple exponential smoothing model, we'll update that based on the errors it is producing. And these are the formulas we're going to use. So we have an error formula and the M formula that we use. Here are the formulas for that. So initially M sub t will be equal to E sub t. That's our initial value. And then we use these two formulas to update E sub t and M sub t. And this is the formula for updating the alpha value. So now let's go to the Excel file and illustrate this. So let's start with a delta value. Okay, delta is the smoothing coefficient for E sub t and M sub t. And this is a simple exponential smoothing is what we're going to be using. So our initial value, like way back in the SES tab, we'll use the actual value from time period 1 as the initial forecast for time period 2. So E sub t will be actual value minus the forecast, and then absolute value of that error. E sub t and M sub t, initial value of uppercase E sub t is the error, and for M sub t it is the absolute error. Okay, now the alpha value, okay, the formula is absolute value of E divided by M. So you have absolute value of that divided by M sub t. So now we have an alpha value for this row. So the forecast is the previous forecast plus alpha times the error. Okay, then sales minus forecast, absolute value of the error. Now E sub t and M sub t, the formulas are, so you take delta must be absolute referenced, times lowercase e sub t plus 1 minus delta, absolute reference that as well, times the previous uppercase E. And here it will be delta, absolute reference that, times the absolute value of E plus 1 minus delta, absolute reference that also, previous M sub t. So now we can copy these. Then we extend that alpha to the next time period and find the forecast for the next time period. Once we have the actual value, then we can set up the next forecast. Now we can run, we need to set up the error measures. Okay, exactly same as before. So we're using observations from 5 through 12 in our measures. So average, ME, RMSE, and so on. Now of course we can run solver. Now we want to minimize RMSE and we want to see what the smoothing constant should be. and we want that smoothing constant to be between 0 and 1. Solve, and we get the best tracking signal constant.